in this session, I will talk about the absolute intensity calibration and then also the background subtraction. So in order to do that, in order to do the absolute intensity calibration, we need to calculate the transmittance of sample, and also we need to calculate the conversion factor from the measured intensity to the absolute intensity. For that purpose, you need to you need to measure the several standard sample and then background images. Okay. Typically, standard sample we use classic carbon and water as an intensity calibration, absolute intensity calibration. Okay. First of all, if you have all the images ready to go, images are ready to go, then first step, what we need to do is choosing the spec file, okay, by clicking the 12ID spec file. So particular, this set of data, this file was the spec file, okay. So I select that one. And then if you turn this button on, whenever you click the data like this, okay, the software will read the spec file and extract out these measurement related informations like a file name, exposure times, photodiode values, X-ray energies, like the motor positions, temperatures, and things like that. Okay. Now the air data. Okay, so air data means the data measured without any sample environment, sample setup. Okay, so here I loaded this air image. It looked like this. So click this button and then right click. Then you can see set current image as an air, right? So I did. Okay, and if you want to subtract the background from the measured data, you also need to choose the background too. Okay, but for this particular set of experiment, so my background is also this air. Of course, background can be different for the sample by sample. Okay, so anyway, but then, well, you can really redefine the background anytime if you want to. Okay, so for this case, I will define this one as a background as well. Okay, so I define as a background. Okay, so once you define the background, and so software will, you know, calculate the transmittance, okay, of the background. Of course, in case of transmittance of background is 1, because air was also, and the air and background was they are the same, so the transmittance should be just exactly 1, right? Good. So let's open some other real images, sample images. Okay. So if you click any data images, now what you can see is these images. Also, you can see the information about that particular, okay, the data set. Here, data set, right? That's good. Mm. If you want to now calculate the intensity, which is in this case like thousands of count, as you see. Excuse me. So that's the count. We want to convert this count in the centimeter inverse unit. As I said, we need a standard sample, which is glass carbon in this experiment. Okay, so I load glass carbon data. So intensity of the glass carbon data is well known. I mean, this is calibrated sample. For now, we need to find the scale factor that brings this measured count into the absolute intensities, right? In order to do that, okay, there's a button. This one, use the classic carbon L17 for calibrating absolute intensity, right? Okay. But when you do this, before you actually loading this, make sure you didn't select any option here, okay? Well, you could have subject the background if you want to, okay? And so double click it. Yeah, this is a background subject image because the air scattering compared to the glass carbon scattering is very weak. So after even background subtraction, it's almost you don't notice any difference. Anyway, so I did the background subtraction, and then by clicking this one, okay, and we can get the scale factor. Scale factor is okay, already put it into the here. Also, the I0 reference, what does it mean is this is a beam flux when we measure this standard sample. Okay, now all the data will be measured, well, rescaled according to the this incoming flux. For now, well, that's not important. So this line, okay, blue line is the calibrate standard sample curve. Okay, that's already um, generated by other people's. And then the red dots are these images. I just picked some, particular area and integrated intensity and plot against the absolute intensity calibrated curve, right? So based on this comparison, we found that this is scale factor. Okay, good. So once you do this, everything is ready to go. Okay, only one thing you have to maybe worry about is sample thickness. Okay, sample thickness. Here's I picked the sample thickness, 1 millimeter. Okay, uh, for all the data, I measured here. But you can change if you want to, but also if you need to. Okay, but let's see. And then if you want to apply if you want to calculate the absolute intensity, you need to pick all of these options. And okay, so when also you want to do when you click these options, you will need to select normally how you normalized, what is the incoming beam flux, the parameter was. So you just pick IC. IC is for the incident beam intensity. And then you will also calculate the transmittance, and then you also apply the sample thickness. Okay. So for now, let's just say 1 millimeter. Okay. And then you also will subtract the background. Good. So let's just see what the software will do. So these are the actual images, and then if you click it, the software will calculate the transmittance of this sample. Okay. And also it will spit out the incident flux, how much it changed since it was measured the background samples, which is air, right? So the flux was decreased by from like this much, but it's not no. Flux is almost close to the actually there is not much flux difference, right? Good. Okay. Now the intensity is now the absolute scale. So this one is count is here. You can see the 144, right? But that's now previously it doesn't have any unit, but now it has unit, which is a centimeter inverse. Okay, and you can do the line cut also if you want to. Okay, click on it, and probably along the azimuth angle 0, right? Almost phi equals 0, and then do the line cut. So then you can see this. Okay, the intensity here profile is now in the absolute scale. Okay, it's not the arbitrary scale. So the y-axis unit will be centimeter inverse, and x will be angstrom inverse. Okay. Of course, you can do the averaging as well. You can do the azimuth averaging with this Sachs tool. Okay. Good. That's about it for the absolute intensity calibration. Oh, one thing that I missed is maybe the sample thickness. If you think your sample thickness is different, then you change this value. Let's just say it was 1.1 millimeter, okay, and then reload data. Okay, then the new image will be okay, the recalibrated image. So what does mean is if you want to apply this new value, you have to reload the data. Okay. Otherwise, these by clicking these, clicking doesn't mean that this option is applied to the current image that you have on the screen. Okay, so you have to reload the data. Um, then everything will be okay. That's about it. Thank you.